Hey guys, Jim here. Welcome to our SPI test number 2. First off, before we get started, I just want to thank everyone for your wonderful and positive feedback I've received these past few months, and I thank you for your support. Let's get started. Question 1. Which best describes this type of artifact? A. Acoustic absorption. B. Dirty shadowing. C. Clean shadowing. Or D. Acoustic attenuation. The answer is C, clean shadowing. Clean shadowing is described as a uniform darkness posterior to the highly attenuating structure. Dirty shadowing is characterized as having a mix of dark and bright echoes posterior to the highly attenuating structure. But if it's clean like this, mostly uniform darkness, that's clean shadowing. Question number 2. Tissue Doppler imaging, or TDI, uses a low-pass filter instead of a high-pass filter to eliminate the signal from the blood to show color information when evaluating myocardial wall motion because A. Myocardium produces a high amplitude, low velocity signal. B. Myocardium produces a low amplitude, low velocity signal. C. Myocardium produces a high amplitude, high velocity signal. Or D. Myocardium produces a low amplitude, high velocity signal. The answer is A. Myocardium produces a high amplitude, low velocity signal. Question number 3. All of the following is incorrect about the sonographer's position except A. The sonographer's right wrist has an ulnar deviation. B. Sonographer is leaning over the patient to scan. C. Arm is adducted greater than 30 degrees and elbow is straight. Or D. Machine is too close. The answer is D, the machine is too close. Having the machine close is actually correct. Question 4. The x-axis of the spectral waveform represents what? A, intensity, B, brightness, C, distance, or D, time. The answer is D, time. Question 5. If you are using a pulse wave Doppler with a PRF of 3500 Hz, at what point will aliasing start? A, 3.5 megahertz, B, 3500 Hz, C, 1750 Hz, or D, 7000 Hz? The answer is C, 1750. The highest measured frequency measured is equal to 1/2 the PRF. Half of 3500 Hertz is 1750. Once 1750 is exceeded, then aliasing will occur. Question 6. Click in the area of highly attenuation caused by a highly attenuating structure. The answer will be right here. If you look closely, this is a stone right here, which is absorbing the ultrasound coming down, causing a shadow posterior to that structure. So you'll click right there. Question 7. A transducer transmits a 4 megahertz pulse into the body. The returning pulse is reflected back to the transducer at a frequency of 3.988 megahertz. The returning pulse will be displayed where on the spectral Doppler image? A, high above the baseline. B, above but near the baseline. C, below the baseline. Or D, there's no way to tell. The answer is C, below the baseline. Question 8. Which red blood cell will have the greatest positive shift? A, B, C, D, or E? The answer is A, because the cosine of this red blood cell will be 1. Question 9. This sonographer should adjust every single ergonomic position displayed here except A, right shoulder should be in the neutral position. B, right wrist should be hyperflexed. C, right arm should be abducted greater than 30 degrees. Or D, right elbow should be straight. The answer is A. The right shoulder should be in the neutral position. Sonographers should keep their shoulder in a neutral position, which means your humerus will hang down by the side with your elbow bent at 90 degrees and resting on the side of the chair here, while keeping your arm abducted less than 30 degrees, and your wrist should be in the neutral position, not ulnar deviated or radial deviated or hyperflexed. This sonographer should sit up straight, put their shoulder in a neutral position, bend their elbow at 90 degrees while resting their forearm on the side of the back part of this chair. The wrist should be in the neutral position, not hyperflexed. The machine should be closer to the sonographer with the monitor at eye level. Question 10. Click on the artifact caused when the second pulse arrives before the first pulse in this image. The artifact this question is describing is called a range ambiguity artifact, and that is right here. You'll just click that, and you'll be correct. Question 11. Lateral resolution is improved by all of the following except A, dynamic aperture, B, frequency, C, pulse inversion, or D, multifocusing. The answer is C, pulse inversion. Pulse inversion will actually improve spatial resolution. Question 12. Dynamic frequency tuning uses only high-frequency reflections to create superficial portions. If a pulse is transmitted from a transducer at 8 megahertz, what will the range of frequencies be used in deep tissue? A, 10 to 11 megahertz, B, 8 to 9 megahertz, C, 4 to 6 megahertz, or D, 6 to 7 megahertz. The answer is D, 6 to 7 megahertz. Question 13. Which of the following will increase both axial and lateral resolution at the same time? A, spatial compounding, B, temporal compounding, C, pulse inversion, or D, frequency? The answer is D, frequency. Both axial and lateral resolution will increase or improve when you increase frequency. Question 14. While using harmonics imaging, a frequency of 4 MHz is emitted into the body. What will be the transmitted frequency? A, 4,000 kHz, B, 8 MHz, C, 3.5 MHz, or D, 2,000 kHz? The answer is A, 4,000 kHz. Just be prepared to be able to convert from kilohertz to megahertz to hertz. 4,000 kilohertz is equal to 4 megahertz. If you're given 4 megahertz and you want to convert it to kilohertz, you just move the decimal point over to the right 3 times. This is a really tricky question because the key word here is transmitted. If it said reflected, then that would mean you would double the frequency that's emitted into the body, which would equal 8 megahertz. But the transmitted frequency will maintain the same frequency as it was when it left the transducer. Question 15. At what stage is a gas bubble the largest? A, during compression. B, when the MI is 0.1. C, during rarefaction. Or D, at peak amplitude above the baseline. The answer is C, during rarefaction. Question 16. How exactly is color Doppler imaging obtained? A, uses a large gate with many points along a scan line proportional to the width of the gate. B, uses a mathematical technique to break down the signal and produce color Doppler imaging. C, phase quadrature permits color Doppler display by distinguishing positive and negative Doppler shifts. Or D, ignores the frequency shift information and focuses only on amplitude and strength of the shift. The answer is A, uses a large gate with many points along a scan line proportional to the width of the gate. Question 17. The process of using multiple pulses per scan line to produce color Doppler is called what? And what happens when it increases? And what does this mean for temporal resolution? A, pixel density becomes more sensitive and increases temporal resolution. B, pulse inversion becomes more sensitive and increases temporal resolution. C, ensemble length becomes more sensitive and decreases temporal resolution. Or D, multifocus becomes less sensitive and decreases temporal resolution. The answer is C, ensemble length and becomes more sensitive but decreases temporal resolution. So the process of using multiple pulses per scan line to produce color Doppler is called ensemble length or packet size or packets, which makes it more sensitive and makes it more accurate so you can pick up higher velocities at the expense of temporal resolution because the more pulses you use per scan line will decrease your temporal resolution. Question 18. When using color Doppler, non-moving structures are reflected as what? A, complex mix of frequency shifts and time. B, duplex imaging where the B mode image is displayed on the screen. C, complex signals that are broken down by frequency. Or D, shades of gray. The answer is D, shades of gray. Question 19. If the oscillator vibrates at 2 million times per second, the continuous wave transducer will operate at what frequency? A, 2 million megahertz, B, 2000 kilohertz, C, 2 kilohertz, or D, 4 megahertz? The answer is B, 2000 kilohertz. The amount of times that the oscillator vibrates per second is equal to the operating frequency of a continuous wave transducer. Also, just like I said before, make sure that you're able to convert from one unit to the other, so you're not confused on your boards. Question 20. During the process of cavitation, gas is drawn out of a solution during when? A, transient stage, B, compression, C, rarefaction, or D, mechanical index of 0.1. The answer is C, rarefaction. Question 21. Click on the ranged ambiguity artifact. The answer is right here. Question 22. All of the following are ways heat is lost from the body except A, evaporation, B, vaporization, C, conduction, or D, convection. The answer is B, vaporization. Question 23. TDI is limited by frequency shifts at 90-degree angles. Since the myocardial walls are oriented at 0 degrees to the beam in some views, what does this mean for the image? A, this limits accurate TDI measurements. B, the myocardial walls should be oriented to at least 60 degrees. C, this is not a limitation. Or D, TDI should not be performed. The answer is C, this is not a limitation. Question 24. Which of the following is referred to as collapse? A, stable cavitation, B, transient cavitation, C, streaming cavitation, or D, radiation cavitation? The answer is B, transient cavitation. Question 25. Axial resolution is improved by all of the following except A, shorter pulses, B, damping, C, wide bandwidth, or D, higher sensitivity. The answer is D, higher sensitivity. Higher sensitivity means that there's no damping layer, meaning that the transducer can't reduce the ringing from the pulse. Well, that concludes our first 25 questions of this test. I do have, however, 4 bonus questions just in case you're taking your board soon. So bonus question number 1, an 85-year-old patient needs to have surgery, but they can't sign the consent form because they are in a coma. Which of the following can sign the consent form? A, the OR nurse who happens to be the patient's nephew, B, the surgeon performing the procedure, C, the neighbor who has power of attorney, or D, the divorced spouse. The answer is C, the neighbor who has power of attorney. Bonus question number 2. Which of the following will reduce slice thickness artifacts? A, decrease depth, B, increase frequency, C, apodization, or D, 1.5 dimensional ray transducers. The answer is D, 1.5 dimensional ray transducers. Bonus question number 3. Which transducer will have the highest Doppler shift? A, B, C, or D? The answer is A, because all the red blood cells right here flowing towards transducer A will have a cosine of 1. Bonus question number 4. Color flow Doppler provides what type of information? A, mean velocities, B, peak velocities, C, magnitude and speed, or D, direction and mean velocity. The answer is D, direction and mean velocity. And the reason why we can determine direction with color flow Doppler is because we have that color map displayed on the screen. Well, that concludes our SPI test. Again, I want to thank you all for your wonderful support that I've had these last few months. If you're in need of more help in tutoring faster than I can crank out these videos, you can go to our website, ultrasoundboardreview.com, and sign up for our SPI tutoring, and I will personally help you with everything you need to know for your SPI boards. We also have mock exams that you can purchase on our website that have questions that are very similar to your SPI boards. You can email me anytime at ultrasoundboardreview@gmail.com, and I will answer you as quickly as possible. Or if you need quicker responses, just text me on my phone at 435-922-1635. I'm Jim with ultrasoundboardreview.com. Thank you so much for watching.